Okay, so I received some emails and some students requested to uh, discuss more examples from sigma notation. Okay, so this video is for for the request. Okay, so we're gonna look at four examples, and then hopefully after this video you can feel more comfortable about the sigma notation. The basic idea of sigma notation is to add a bunch of numbers together. Okay, so look at the first one. So sum k from 2 to 5, and the case term is -1 to the power of k times 2k plus 1. Okay, if I want to calculate this, okay, this summation, and what I can do is I can list all the terms and then trying to do the basic operation, either plus or minus. Okay, and also be careful here. K starts from 2, so when k equals 2, this is gonna be -1 squared plus multiply 2 times 2 plus 1. Okay, and then when k equals 3, it's -1 cubed 2 times 3 plus 1. When k equals 4, which is -1 to the power of 4, 2 times 4 plus 1. And when k equals 5, which is -1 to the power of 5, 2 times 5 plus 1. Okay, so that's how to do this calculation. And you can see, guys, I can simplify this. -1 squared, which is positive. This part is 5. Okay, -1 cubed, which is negative, and then inside of the parentheses it's 2 times 3 plus 1, which is 7. Okay, so it's -7. And -1 to the power of 4, which is a positive, and inside you can calculate it's 9, so it's a plus 9. And then the last one is going to be -11. Okay, so how do we calculate this? Fairly easy, right, guys? So you're gonna see that you're gonna have it's -4. Okay, -4. So that's how do we do this sigma calculation. Now let's move on to the other one. Okay, so 1 and 2 are very straightforward. So when k equals 3, so you have 3 over 3 plus 1. When k equals 4, you have 4 over 4 plus 1. When k equals 5, you have 5 over 5 plus 1. Okay, so this is 3 over 4 plus 4 over 5 plus 5 over 6. Okay, so you can let them to have the same denominator, which is the least common denominator, which is a multiple of those. 4 times 5 is 20. 20 times 6, which is 120. Okay, so what I'll do here is 120. For here you need to multiply 30, so you have 90 here, plus 120. 20, you have to times 24 to 5 to give you 120. So 4 times 24 is 96, plus 120 times 100 over 120. Okay, and then you can add them together. I believe this is going to be 286 over 120. Okay, yeah, and of course you can do a little bit simplification, but up to there it's all good. So those are the first two examples. Next one. Okay. Let's look at this. Okay, so it's a summation of k from 51 to 100. Okay, so let's see, so 51, right? It's because started from 51 plus 52 plus 53 up to 99 plus 100. Okay, 100. And how do we deal with this? Well, we discussed the sum of first n integers, right, guys? Remember that? And then, so this sum of n integers, actually it's starting from 1. In other words, if we are adding summation k from 1 to n, k, which is 1 plus 2 plus 3 plus up to n, and we introduce that formula, right? Which is n times n plus 1 over 2, okay, over 2. So that's what we already discussed. Then let's try to think about it. How do we do a link from the sum of the first n integers formula, which is here. Again, start from 1, okay? And then to this problem. So 51, 52, 53, up to 100, right? Now guys, let's think about this. Do you agree that use this formula, I can easily, let me write it into this way. Do you agree I can easily calculate the summation from 1 to 100? Which basically just substitute n here to 100, right? So that's gonna give you is 1 plus 2 plus 3 plus 4 plus 5 up to 100. Okay. But look at what we have here. We start from 51, right? So do you agree if we can get a sum of 1 to 100 and if I can make a subtraction about the numbers from 1 to 50, do you see this is exactly what we have? You see that, right? So for those two, it should be very straightforward to calculate it. It's gonna be 100 plus 1 over 2, sum of the first 100 integers, minus 50 times 50 plus 1 over 2. Those are the summation of the first 50 integers, starting from 1. And the difference, the subtraction, do you see is exactly the summation from 51 to 100, right? So that's the basic idea to solve problem 3. Okay, of course, if you have a calculator, you can calculate those numbers out. Okay, so that's number 3. Let's look at the last one. Okay, so k from 5 to 40, and inside the parentheses is square root of k minus 3 minus square root of k minus 2. Okay. So for this problem, if we only look at this problem, it seems like there is no formulas, right, to do the calculation. And all we need to do is to write down each term out and then to see if there are some patterns we can make use of. Okay, and okay, so let's see. And also guys, never use a calculator to calculate the radical numbers, especially when you are in a sigma notation problem. Okay, and later on in calculus 3, and if you have a sequence problem, and similarly, if there is a radical get involved, often there are a lot of cancellations involved. Okay, so do not rush to calculate the digital value for the radical. Okay, let's list them out and see the pattern first. Okay, so this is what I'll do. Let's see, when k equals 5, and then I'm gonna have square root of 5 minus 3, which is 2, minus 5 minus 2, which is 3, right? This is when k equals 5. And then plus when k equals 6, which is square root of 6 minus 3, which is 3, minus square root of 6 minus 2, which is 4, right? This is when k equals 5, this is when k equals 6. And then we can, some of you might already see, there are some calculations getting one. Maybe let's write one more. When k equals 7, so we have square root of 4 minus square root of 5, right? And of course we can just continue this. And then maybe let's put a da da da, and then also write the last two terms. When k equals 39, we have square root of 39 minus 3, which is 36, minus square root of 37, okay? Plus, when k equals 40, so we have square root of 40 minus 3, which is square root of 37, minus square root of 38, okay? It looks like scary, right, guys? But look at what we have. If we get rid of the parentheses, do you realize that only the first term, the first part, and the last part are the survivors? Because minus square root of 3 plus square root of 3, go. Minus square root of 4 plus square root of 4, go. Minus square root of 5, well, they're going to be a plus square root of 5, go. So you will see that there are tons of cancellations here, okay? So only the first radical and the last one are the survivors. So you have square root of 2 minus square root of 38. Okay, so that's the 4 examples. I hope this will help, and thank you for watching. Stay safe.